there is no way you are going to do a terminal exam like Neco or Waec that you are not going to have graph, either a quadratic graph, a quadratic and linear graph combined together, or trigonometric graph, or even cumulative frequency and histogram. You are going to get problems from there. Now this time I'm going to focus on graph, and we'll start with the quadratic graph. Now let's quickly read this. Copy and complete the table of values for the relation y equals 2s squared minus s minus 2 for s is greater than equal to. So I read this: s is greater than equal to 4 but less than or equal to 4. For this is the table. So we have the scale that we're going to using a scale of 2 cm to 1 unit on the s axis and 2 cm to 5 unit on the y axis. Draw the graph of y equals 2s squared minus s minus 2 for x is greater than or equal to 4 and s is less than or equal to 4. C, on the same axis, draw the graph of y equals 2s plus 3. This is a linear graph, so we're going to have our quadratic and linear graph combined together. Then use the graph to find the roots of the equation 2x minus 2x. This should be 2s squared minus 3x minus 5. So that is what that should be. Minus 3s minus 5 is equal to 0. Then I, the range of values of s for which 2x minus x minus 2 is less than 0. So let's quickly take that. Here you see that I have two tables. You can either use this table or you use this. Now to me, if you want to use this table, you must have to show clearly how you arrive at all this value. But if for this table, you can just draw the table and put your value. So this is going to be minus 4 squared, that is 16. 16 times 2 is going to be 32. Minus 9 squared is 9. 9 times 2 is 18. I said minus 3 squared rather. Minus 2 squared is 4. 4 times 2 is 4. Minus 1 squared is 1. 1 times 2 is 2. 0 squared is 0 times 2. 0. Then we have 1 squared is 1 times 2. We have 2. 2 squared is 4. 4 times 2 is 8. Let me come back to this. Minus 2 squared is 4. 4 times 2 is 8 rather, not 4. Then I have 3 squared is 9. 9 times 2 is 18. 4 squared is 4. 16. 16 times 2 is 32. Then I have minus s. Minus s is minus times minus 4. That's 4. Minus times minus 3. That's 3. Minus times minus 2. That's 2. Minus times minus 1. That's 1. Minus times 0. That's 0. Minus times 1. Minus 1. Minus times 2. That's minus 2. Minus 3. Minus 4. So we'll just add all of this together. So I have 32 plus 4. That's 36. 36 minus 2. That's 34. 18. Okay, 3 minus 2 is 1 plus 18. That's 19. Then I have 2 minus 2 is 0 plus 8. That's 8. Then I have 2 minus 2. That's 0 plus 1. 1. So this is the table. Now you notice that this, I put minus 2 all through here because here we have a constant. There is a constant, so it has to go all through. Now for the other part, all others have already been fit, so you can just get this. The equation is y equals 2x squared minus s minus 2. So you see when x is equal to minus 4, y is just going to be equal to 2 into minus 4 squared minus 4 minus 2. So you just work everything out. So I'm going to have 2 times minus 4 squared. So this is going to give us 34. So that's 16. 16 times 2 minus times minus plus, that's plus this minus 2. That's going to give us 34. So now you say when x is equal to, so we have already gotten the answer for this, minus 2. Y is going to be equal to 2 into minus 2 squared minus 2 minus 2. That will give us 4 times 2, that's 8, plus 2, that's 10, minus 2, that's 8. Then you go to the other part. So you can feed this here 34. So this is the updated value. You can just check through this. Then I've used it to fill the table. So either way, I personally prefer this because it does not occupy so many space. But anyone that you prefer, you can use it. So let's plot the graph. So we are asked to use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 unit on the y-axis. Draw the graph of y equals 2s squared minus s minus 2 for s is greater than or equal to 4 or less than or equal to minus 4. So on your graph, each of these bars represents 2 cm. So they said that we should take 2 cm to represent 1 unit on the x-axis and also 2 cm to represent 5 units on the y-axis. Now this is what I'm going to do. I'm going to use the x-axis to draw my y-axis. How do I do that? Let me start from this point here. The least value of x is minus 4. It's minus 4. So I'll just extend that to minus 5. So if I say this is minus 5, minus 5, minus 4, minus 3, minus 2, minus 1, this is 0, 1, 2, 3, 4, 5. So this point will be enough for me. So I'll draw my y axis through this place. So I'm going to draw my y-axis through this point here. So this gives my y-axis. Again, this is because I'm using 2 cm each. Minus 5, minus 4, minus 3, minus 2, minus 1, 0. So my 0 fits into this. Now to draw my x-axis, I'm going to use the y-axis. Now you can see this. The greatest value of y is plus 34, and the least value is minus 1. So I can shift this to 35 and do this. This is going to be on the positive. This is 35, 30, because I'm using 2 cm to 5 units. 30, 25, 20, 15, 10, 5, 0. So I can draw my x-axis through this. So by doing this, I will not have any problem getting my x and y axis. So I'm going to draw this. Now we have to label. On this is going to be minus 5, minus 4, minus 3, minus 2, minus 1, 0, this is 1, 2, 3, 4, 5. So we can go for the y-axis. So I'm going to have 35, 30, 25, 20, 15, 10, 5, 0, minus 5. I think this is enough because the least value of y was minus 2. Okay, but it fits into this. Now the next thing you have to do is to know the division on each of this line. Now look at this. On this line I have 10 values and the gap between this and this is 5. So I'm going to have 5 divided by 10. That gives me 0.5. So it means each of this line is 0.5. Each of these smaller lines. So this is 0.5, 1, 1.5. Or let me start from here. This is 0, 0.5, 1, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Now you get that. So that you're able to plot at the point. But we have integers actually. So it means that each 2 of the lines should be 1. When you combine 2 of the lines together, that gives you 1. So let's quickly plot the point. When s was minus 4, I had y is what? 34. So I can come to this with minus 4, and I'll read off 34 from this. Remember that 2 of the lines are 1. So I have 2 away from 35. So I have here, I'll come to this place. This is 30, 31, 32, 33, 34. So I'll mark this point like this. Then I have minus 3 for 19. So this is minus 3. This is going to be, this is 15, 15, 16, 17, 18, and 19. So you put a point like this. Then minus 2 for 8. I have minus 2. So it's going to be close to this. I have 5, 6, 7, and 8. I'll put a dot like this. Then I have minus 1 for 1. So I have this. This is minus 1. This is 1. Yeah, put a dot like this. Then I have 0 for minus 2. When s is 0, when s is 0, y is minus 2. So I have minus 1, minus 2. I put a dot here. Then I have when x is 1, y is minus 1. So this is 1. So this is minus 1 here. Put a dot on this. Then the next one, when x is 2, y is 4. So I go up. This is 5. I go 2 places downward. This is 4. Then when s is 3, I have 13. So this is 10, 11, 12, 13. 2 spaces each. Then I have 4. When x is 4, y is 26. So this is 25. And this is 26. 2 places from 25. So the next you have to use, if you have a French curve, you can use that to draw the curve. But if you don't have a French curve, if you have, your hand is smooth, you should use pencil so that you can erase it. But I can draw this with free hand through this gently, through this, through this. You have to rotate, draw this through this. If you don't have French curve, use a broom to draw it through this, but you can draw it gently like this by turning this. We are good. So my curve is perfect. I know that. It is perfect, even using free hand. So let's look at what they asked us to get from this. So they said on the same axis, draw the graph of y equals 2x plus 3. So let's draw that. Now to draw the graph of y equals to 2x plus 3, pick any 3 points. Any 3 points that suit you. So I'm picking minus 4, 0, and 3, 4. I can pick minus 3, 0, or and 3. Just pick any 3 points. So this is a constant. 3 will go all through. Then I have 2x, 2 times minus 3, that's minus 6. 2 times 0, that's 0. 2 times, that's 6. So minus 6 plus 3 is minus 3. 0 plus 3 is 3. 6 minus 3. 6 plus 3 is 9. So again, we'll come to this, our graph again. So I'm going to plot when x is minus 3, y is minus 3. So I'll come to this place. When s is minus 3, I count from here. 1, 2, 3, minus 3. I put a dot, I put a cross here. Then when x is 0, y is 3. So when s is 0, 1, 2, and 3, I put a dot here. Then finally I have when x is 3, y is 9. So I have this is 2 places from here, this is 9. So I will take my ruler and draw a straight line through these 3 points. Okay. So there is something you need to know. You must write the equation of the each of the graph there anywhere on this. So y equals 2x squared minus x minus 2. That's the curve. Then for the straight line, you can write it anywhere also. Y equals 2x minus 3. And don't forget to write your scale. On the x-axis, we have 2 cm to 1 unit. 1 unit. And on the x-axis, we have 2 cm to 5 units. So the straight line is actually 2x plus 3, not minus 3. So I've corrected that. So we have the scale, then the graph. So we have two graphs here. Graph of first one is y equals 2x squared minus s minus 2, and y equals 2x plus 3. These are the titles of the graph. That is very important you put this and this. Now, so we are done with that. Then the D part of it, they said we should use the graph to find the root of the equation 2x squared. Let me get the root of that equation. 2x squared minus 3x minus 5 is equal to 0. What it simply means is that the point where these two graphs touches each other. In fact, first of all, the first graph, the quadratic graph, is 2x squared minus x minus 2 is equal to where they intercept 2x plus 3. That is the linear graph. So just push this one this way. You have 2x squared minus x. Push this one, you have minus 2x minus 2. Push this one this way, you have minus 3 equals 0. So this is going to give us 2x squared minus 3x minus 5, which is the solution to what they asked us to look for. So this is the point. Just trace this point downward. You can take your ruler and trace this point downward and put it there. We estimate your values from here and trace this one down on the x-axis and estimate your values from here. So from here, on the x-axis, we are using 1 cm to 1 unit. So each of these divisions is going to be 0.1. So I have, this is 2, 2.1, 0.2, 0.3, 0.4, 0.5, and the midpoint 2.55. So I'm estimating my values. X is equal to 2.55, or x equals, then I'm going to estimate my value from this point. So this is going to be minus 1. So you are, on this side, you are reading this way. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's minus 0.9, and the midpoint minus 0.95. Minus 0.95. That answers the first part of that question. Then they now said, for what range of values of s, we should use the graph to find the range of values of s for which 2x squared minus s is less than 0. We should look for the range of values of s for which this curve here crosses the x-axis downward, where y is less than 0. That is what it simply means. It simply means the point where y is less than 0. Are we following? And this is your y-axis. All values from this point downward are less than 0, and these are going to be the point from here to this point here. So we read off these values from here. So we're going to have, let me just write that this way. So we're going to have, okay, let me read it from here. I'm going to have here, x, put this in the middle, is greater than or equal to, okay, it's going to be greater than because they said less than 0. S is greater than, so read all the values from here. So this is going to be minus 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.75, minus 7.5, minus 0.75 rather, minus 0.75, x is greater than minus 0.75 but less than, then you read this value. This is 1.1.25, 1.25. So these are the range of values of s for which this curve is less than what? 0. So that's all for this. We'll move on to the next graph.